Awesome. Okay, everyone. I'm going to stop presenting. Actually, I think I already did. I will pass it over to our speakers at this point, and they can begin presenting and begin our presentation.
All right. Hello, everyone, and welcome. I am Julia Elliott, Kaggle's interim CEO, and I am really excited today to be sharing some insights from Kaggle's recently concluded annual user survey focused on working data scientists. Just a tip on the presentation, there is a way to expand it to full screen in case you're having trouble reading some of the graphs that we have with some of the finer details. All right, so this is Kaggle's 5th year conducting an in-depth survey of our data science community and publishing the results. Over 25,000 data scientists and ML engineers submitted responses this year to over 40 questions on their backgrounds and day-to-day experience. This covered everything from educational details to industry experience to preferred technologies and techniques. But what excites us most about open sourcing the anonymized data year after year is bringing Kaggle's community into the dialogue about what insights can be gleaned from this rich data source. So to further incentivize engagement and collaboration on the data, we are hosting a competition and awarding prize money to the most insightful analyses offered by our global community. I promise to share the competition details prior to the Q&A section of this session, so please do stay with us to the end. We've also released an executive report to kickstart industry conversation about the data. This report is focused only on a slice of the data, the 14% of respondents who are currently employed with the job title of data scientist. It's a follow-up analysis to reports that we've published in the past in both 2019 and 2020 with the same criteria. Our aim in narrowing down to this slice is really to establish consistency year over year in the population that we represent by the report, and to increase focus on the professional data scientist. Now, we acknowledge that this may be an oversimplified view, but we believe this segmentation to be representative of overall trends nonetheless. Now, to give you a sense for how we at Kaggle have developed our survey over the past 5 years, we initially modeled it after Stack Overflow's Developer Survey, but with a specific focus on data science and machine learning. We structured these questions intentionally to cover a lot of ground. So the purpose being both to A, provide a holistic picture of data science landscape from demographics to education to industry trends, and also B, to offer a rich volume of data for our community to dig through. Over the years, we've really learned quite a bit about what Kagglers care most about analyzing, and therefore have calibrated the survey's composition. For example, in 2018, we introduced an expanded category around enterprise products, as we were seeing that dimension become increasingly important for analysis of industry trends. Now, that brings us to today's session. We'll share some of the raw data and trends from our executive report, and discuss these findings with our panel of data scientists and machine learning product leads. I'll center our discussion today around key findings grouped into 4 categories presented in our report. One being the data scientist profile. Second, education and machine learning experience. Third, emerging technology trends. And fourth, maturity of machine learning in business. And I'll step through each of these sections organized around charts that present key findings of the report, and then check in with our panel of data scientists and machine learning practitioners to hear their stories and their firsthand accounts of how this data translates into their experiences. All right, with that, let's meet our panelists. So in addition to Paul, Mooney, and I, and Paul is joining us from Kaggle, where he's our data scientist and developer relations engineer. We also have Ruchi Bhatia, who is a 2-time Kaggle Grandmaster and current graduate student at Carnegie Mellon University. Bilbo, who is a software engineer at Waze. Sionek, a senior data engineer at Gousto, and our winner of Kaggle's ML Survey Data Challenge from last year. Lastly, Henry Tappen, Google Cloud Technology Leader. Kicking things off, let's start with the data scientist profile and some data around demographics. As you can see here, data science as a field is still suffering from a large gender gap in the workplace. Even in 2021, 82% of users identify as men. And looking over the past 5 years, there really hasn't been a meaningful change in gender distribution. When we look at the survey data from an age perspective, data science remains a fairly young profession, more than half of all data scientists being between the ages of 22 and 34. Even country demographics are nearly the same as last year, with 2 countries having far more representation in the Kaggle community. First being India, which makes up 24.4% of Kaggle data scientists, and 12.2% residing in the US. Brazil is a distant third at under 4.3%. Data scientists live and work all around the globe, and more than 40% of survey respondents actually live outside of the top 10 countries where we had the most respondents. All right, so let's see what our panel has to say about the data I've presented on the data scientist profile. Kicking things off, my first question is directed to Lauren. What has been the impact of these demographics in data science for you personally?
Yeah, so I'm actually a software engineer. I'm not a data scientist, but I think that the story is very similar between the 2 fields. There's a lot of commonality. I've worked on teams both where I'm the only woman or maybe one of 2 women, and teams that are closer to 50-50 male-female. And just for me personally, I find that it's just such a world of difference between the 2. And the best way that I can describe it is being the only person on the team of a certain identity. I wasted so many brain cycles just thinking, like, double thinking things, thinking, I got this feedback. Is it because I'm a woman, or is it because it's actually quality feedback? And when I actually moved to a team that was more balanced and had more people with my identity, I found that I was actually able to, like, reclaim those brain cycles and apply it to my job, which was pretty cool. I was like, wow, this is like how everybody else feels. So I think that really, like, for me, the biggest thing that we can shift is getting a critical mass of different identities. And I think that we're sort of like behind that tipping point in the data science field where we don't have a critical mass of women and probably other underrepresented groups as well. And so because we don't have that critical mass, those 1 or 2 onlys are just leaving and it's increasing attrition. And so we really need to, like, surmount that tipping point and get that critical mass so people feel comfortable and have the confidence to stay in the field.
Absolutely. Thanks, Lauren. I can definitely identify with that experience. I'd like to turn it over to Ruchi now. As a Kaggle Grandmaster and data science graduate student, what has been your personal experience as a woman in the field of data science?
I noticed the gender disparity for the first time when I was choosing my undergraduate major as computer engineering. For data science, the numbers are even more skewed, and it made me feel a little disheartened, but it didn't stop me from stepping into the field. And I'm glad I chose to pursue my interest in the domain. Sometimes even a little bit of motivation is all people need to keep going when they are faced with crossroads like these. And I believe that data science is a domain for people from all walks of life, and gender shouldn't be a limiting factor for anybody. In fact, all the work that we do is even better with the amount of diversity we have in a team.
Fully agree. Henry, slightly different question for you. As a product manager, how do you think about demographics as your teams are building products for data scientists?
Yeah. Very good question, Julia. I mean, at the end of the day, like, working for a large tech company, especially in the data science field and being a leader in it, I think we, fortunately at Google, and in my group in particular, try to bear this responsibility that, like, we can shape the way that the tools, the way that we talk about, and the way that we open this up to more audiences. with what we launch and once we choose to launch it. There's a lot we consider. There's a lot we have to do in the way that we fix hiring, in the way that we present and promote people inside of our organizations as a way of giving representation for it. There's a lot we have to do for it, but I want to focus on two efforts which I'm pretty proud of that we've done for it. The first is, in a sense, like reaching out, going externally as much as possible, and making sure that as many people who are interested in data and data science have access to the tools that they need, as well as the representation for it. So one of the things that Google Cloud decided to do as an all-up effort was we've made all of our Coursera courses and the materials through the new Google Cloud Skills Boost available. So in fact, everybody in this room, if you're interested in it, should go ahead and sign up for it. You'll see the links over in the Google Cloud Next parts of it. So we try to make those things available so that to correct some of these historical imbalances that are, I think, preventing access to certain groups and not having it happen. The second thing that I think we do is when we look internally and we think about any products we do, Google has a long set of AI principles that, among other things, encourage us to reconsider AI as a tool for that, in its worst case, could just be perpetuating the status quo, and instead push to see how do we use it to really drive important change, especially among groups who are underrepresented, both as users and as creators of AI. So everything that we launch and everything we do kind of comes with the AI principles, both as something that motivates us in the way that we build it. And before we release it, we ask ourselves, if we're going to launch something, does it really comply with these principles, and does it actually improve it? I'll admit, like Google, and in fact, all major tech companies, we have a lot of work to do, right? The fact that I'm a white male up here saying this is part of the problem, but I think we at least in my group understand this responsibility and take it very seriously, that we need to make sure we're building products that are available to all groups and that we talk about them in a way that's very inclusive.
Absolutely. Thanks, Henry. Love the championing of the democratization of AI. All right, so now let's switch gears to a topic that is of great interest to me, education and machine learning experience. So let's see what users had to share with us in this segment. First, in terms of having a degree, being at least a graduate continues to be the norm for data scientists, with over 62% having obtained either a master's or a doctoral degree, and fewer than 5% of data scientists having no degree beyond a high school diploma. However, it is becoming more and more common to be employed as a data scientist without an advanced degree. When we look at experience in the field of machine learning, slightly more than 55% of data scientists have less than 3 years of experience. Less than 6% of professional data scientists have been using machine learning for a decade or more. And from a geographical and country perspective, data scientists in the US have more machine learning experience than their global peers. So the first set of questions here, Ruchi, given your experience having worked in India and then in the US for your studies, could you share a little bit more about how you overcame some of the disparities reflected in the data to land yourself your data science job and then a place in a prestigious graduate program?
So since I was looking to move from my home country for my graduate program, naturally I was seeking opportunities outside my country. So when I was looking to get started, I really didn't know where to start. And that's when I started Kaggle. It's actually a significant part of my data science journey, and it helped me showcase my work on a global scale and motivated me to stay consistent. The exposure offered by the platform was tremendous in terms of helping me upskill my knowledge while working on practical as well as real world problems. And I think my key takeaway here would be working on problems that are relevant in the domain really helps, even if it's taking a while, because in the long run, that helps us to increase our self-learning experience.
Nice, thanks for sharing that. And Andre, I understand that you've worked in 2 different markets, Brazil first and now the UK. Could you share a little bit about your experience having worked in these 2 different markets? And you may need to unmute if you have not yet.
Or click on the broadcast button.
I was out of the broadcast.
There we go.
Sure. So I have worked in Brazil and here in the UK. So there is a difference, a disparity between countries. But when you look like inside Brazil or inside UK, there is not too much disparity. Things are more kind of balanced. And my personal experience from moving to Brazil to the UK, it was a huge kind of uplift in terms of salary and experience with different ML tools and different platforms in general. And I think what really helped me to achieve that was in 2018 when I did the first Kaggle challenge. I believe at that time I won the third place in the competition. And like a few months later, I changed jobs. I went to another startup. And like 6 months later, I got an offer to come to the UK. So like working on something like this Kaggle challenge brought a lot of visibility to my profile. And I asked the recruiters, like, how did you find me? And they said, oh, I went on LinkedIn and I searched for Kaggle Brazil and your name came up. So that's how they found me. So solving a challenge like that brought a lot of visibility and helped me move from one market to the other. And yeah, I'm really happy here.
That's awesome. I love that story. All right. My next question, I guess first the slide with data is that data science and machine learning techniques rapidly progress. And so I guess it's no surprise that most Kaggle data scientists maintain ongoing education. Coursera does remain the most popular ongoing data science learning resource, but we are also seeing strong growth of Kaggle's Learn courses and Udemy. Paul, this question's actually to you as someone who's on the Kaggle team. What are some things that you feel like differentiate these different learning options?
Great question. There are a lot of different places where one can learn about new concepts in data science. And I've used quite a few resources myself during my own learning journey. Coursera seems to be the most popular learning platform for data scientists, and it's where I spend the most time myself. And I think that's because Coursera has such a large inventory of really high quality courses. For example, there's currently a promotion that gives you access to more than 3,000 courses for only $60 a month. And these courses are normally very high quality, and they were often made in partnership with accredited universities. Whereas other options, like, for example, Kaggle Learn courses, I think these courses are especially differentiated as compared to the paid courses you might find on Coursera. You won't find video lectures, but everything will be totally free of cost. And the approach to learning is just very hands-on, where you're encouraged to apply the skills you learn to new projects using new data sets. And these Kaggle Learn courses are especially great if you want to learn something new, but you don't necessarily want to commit to a paid course or take a course that takes an entire semester to complete. So yeah, to answer your question, there are a lot of great options, and I think maybe Coursera is the most popular because of how nicely they've managed to achieve both a large quantity of courses while also maintaining high standards concerning the quality of the courses. But Kaggle Learn courses are a really great option too, not only because they're free, but because they're so hands-on and practical.
Nice. And Henry even mentioned Coursera as a partnership that Google has, so absolutely. All right, so now let's take a look at what users are seeing as emerging technology trends in the space of data science and machine learning. First, users are clearly telling us that the use of large language models, such as transformer networks, your BERT, your GPT-3, et cetera, continue to see strong year-on-year growth. When we look at ML frameworks, Python-based tools continue to dominate the space. Like last year, scikit-learn, which is kind of a Swiss Army knife applicable to most projects, is at the top with over 80% of data scientists using it. TensorFlow and Keras, notably used in combination for deep learning, were each selected on about half of the data scientist surveys. Gradient boosting library XGBoost is fourth, with about the same usage as 2020 and 2019. And then despite being used less frequently overall, we do continue to see strong year-over-year growth of the PyTorch framework. Now, the most popular of the new tools added to this survey this year, which is actually not directly represented on this chart, is Hugging Face, with over 10% of the surveyed data scientists using this framework. So my question related to ML frameworks, let's go to Henry. Could you talk a little bit about the popularity of specific ML frameworks, scikit-learn, XGBoost, PyTorch, TensorFlow, et cetera? Yeah.
Yeah, so being as part of Google Cloud, we work a lot with many enterprises who are trying to implement machine learning to solve their business problems. And among enterprise users, the trends that we hear very, very much match up with what shows up in the Kaggle data. That is, if you look at the universe of problems that people are applying machine learning for, by and large, data scientists are starting with using scikit-learn to apply it to it. What is interesting, though, is we also observe that when it comes to the impact, or rather the importance of the problems that many of our customers are working with, they're starting to skew more and more to using the deep learning frameworks, TensorFlow, PyTorch, and of course the related tools like PyTorch Lightning, Keras, Hugging Face, etc. Now, why would they do this? Why would they only save those tools for some of their most impactful problems? Well, the reality is scikit-learn is a fantastic framework. Very fast, very easy, very simple to get started with while still really good at it. But scikit's problem is that, unlike many of these deep learning frameworks, it's not necessarily built to scale in the same way that they are. TensorFlow, PyTorch, they're harder to get started with. But when you think about every dimension that you might be scaling on, whether it's the amount of data, the size of your model, the different ways that you run data through them, or the different ways that you apply transformations in your data, each additional step and each additional refinement, which could give you improvements to your model, are on the margin relatively easier to do than they would necessarily inside of a scikit world. And so for that reason, we see when companies finally say, okay, here is our business critical, our problem that's going to like change our whole business, while they might start with scikit and XGBoost to start a prototyping, more and more often we see them turning to the deep learning frameworks when they say, okay, now we need to make this a permanent part and a continuously improving process because it's so important to our particular business. Now, on the world of like TensorFlow, PyTorch, you might imagine Google guy, I've got a certain affinity for it. In fact, they're both fantastic frameworks, and we're seeing, interestingly, I think PyTorch becoming very, very common, but also companies also continuing to use TensorFlow quite a bit as well. Yeah.
Makes sense. Thanks, Henry. For our next slide, Jupyter-based IDEs continue to be the go-to tool for data scientists, with around 3/4 of Kaggle data scientists using it. However, Visual Studio Code is growing in the second spot with 38%. Andre, next question to you. What are your thoughts on these IDE trends?
I think there are a few different things behind it. So the first one is, I think there is increasingly more software developers or software engineers moving into data science. So they are more used to using another IDE and not a Jupyter notebook. And I think another reason is the IDEs, they are getting increasingly better in integrating with notebooks. There are different plugins available and different integrations that makes easier for you to use a notebook inside the IDE. And I think the third reason is that when you productionize the models, you usually don't use notebooks for that. And there are different reasons for that. I think the strongest one is that for personal experience, I can say we have our own DevOps platform. And the notebooks, they don't integrate well inside our own platform. So what happens is that we use notebooks for prototyping the ideas, validating the ideas. And then when we are ready to productionize it, we move it to the IDEs where we actually write production code, let's say.
Yeah, that makes sense. All right, for our next slide, the survey data suggests that Google Cloud Platform continues to hold the second highest usage across cloud computing platforms, despite holding less total market share as compared to its top two competitors. Paul, I'm curious why you think that is.
Yeah, I think that is a very important point to raise. Thank you, Julia. I think that maybe there are two main reasons why we found that data scientists were disproportionately likely to use GCP as compared to the overall industry trends. First, I think it's because GCP does indeed have some key technology differentiators that are different from what you can find anywhere else, that are specifically targeted towards data scientists. For example, Google Cloud AutoML and Google Cloud Tensor Processing Units are both great products that allow data scientists to get their work done fast. A second reason, though, is because Kaggle has built integrations with a lot of these GCP products, including BigQuery's Cloud Data Warehouse and Google Cloud's Tensor Processing Units, amongst others. And on Kaggle, you can learn how to use these new technologies and experiment applying them to real-world projects for no cost at all. So I think it's just important to acknowledge that we've really lowered the barriers to accessing some of these cloud computing and data science technologies by providing this free tier. And this likely did have a big influence on the survey response rates, since Kaggle data scientists can try out these exciting technologies without ever needing to take out a credit card.
Yeah, makes sense. So for our next slide, Google Cloud AutoML maintained its top position in the AutoML category at 23.4%. Adoption of Google Cloud's AutoML technology has grown steadily over the past several years, which is similar to the growth that we've seen in TPUs. My next question is for Henry. What are your most common use cases that you see for using AutoML functionality versus, custom models, APIs, or endpoints?
Yeah, I mean, by and large, we see people using AutoML as the first. Well, I guess we see two use cases. The first is AutoML is really good cases where you might not have a lot of data science experience. You might not have a lot of experience with some of the lower level frameworks like scikit-learn or TensorFlow or PyTorch. So especially in tandem with other low-code things like the BQML system inside of Google or Data Robot or other vendors, it's an easy way for people without a lot of deep ML programming experience to produce a model and get it out the door. But secondly, we observe that even for experienced ML developers, AutoML is the best. It's a great first step, right? Which is, when you first get your problem, you first get your data, you shove it through AutoML, and it gives you a good baseline and a good idea. Now, why would you use AutoML instead of like a linear model or something like that? Well, first, if AutoML solves your problem as good as you need it to be, great, you're done. And usually, because the AutoML includes a subset of models, it's going to solve it better than any of the other individual models you might run through it. Secondly, even if it doesn't solve the problem all the way, it gives you some good ideas of where you need to go next, right? Because the AutoML is a very proficient model, and most of the time can solve the questions. Whenever you observe a problem with your model, you need to ask yourself, is it like a data or feature engineering challenge, or is it a model specification challenge? Because AutoML answers the breadth of model specification challenges, it helps you focus down and narrow on the things that humans are really best at, which is looking at your data and the way you've engineered features and figuring out the next step for it. So AutoML is both great as a easy way for people without a ton of data science experience to get their feet wet with models. And secondly, as to be sort of the first step that you'll use to, hopefully it works out in the beginning, and if not, give you an idea of where you need to go next in refining and improving your models.
Yeah, that makes sense, and something similar that we've seen amongst Kagglers on our platform as well. Okay, and that's a nice segue into how the survey data speaks to trends in the maturity of machine learning usage in business. For our first chart, when when comparing responses by country, we do find that data scientists from more developed countries spend more in the cloud than countries which are less economically established. And then looking more deeply at how machine learning is applied at these companies, we are seeing nearly 50% of data scientists working at companies who deploy their models into production. And more than a third of data scientists work at companies with 10 or more people on their data science teams. My first question for this section is to Andre. Could you share a little bit more about how ML is maturing within the organizations that you've worked within?
Sure. I think there are two aspects that I would like to discuss. The first one is that I think companies are doing data science, they're doing machine learning early in their development. And like from my personal experience, I joined a startup in Brazil. The whole startup was like 30 persons. And they hired me as the first kind of data person to start building the data lake and building the data capabilities. And in like 4 months, we had a machine learning model in production. This company was like 1 year old at the time. Now they are 3 years old, and they already have well-established models in production for different purposes. So I think it's not more, it's easy now to find a very young company that is born with this desire to put machine learning into production. And the second aspect, I think more and more companies are linking the ML results to the business problems. And this is also a really good sign of maturity. And for example, where I work now, we have a churn model. And although we have like a recall, we use like a technical metric to measure it, and we care about it when we have like a recall over 0.7, for example. But we also care about how A/B test is doing, and like if we are being able to recover customers versus like with the churn model versus doing coupons randomly to random persons. So it's really important to link the like the models you're building to the business application. And I think this is also something that companies are getting better at, and they're getting more mature.
Yeah, that makes sense. Lauren, so as part of Waze, which is kind of a startup organization within Alphabet, how do you approach ML projects from the perspective of business applicability and KPIs? Could you tell us a little bit more about the recent implementation and the learnings that you may have taken away from that?
Yeah, so first, for some background, I work on the Waze ad serving backend team. So a huge part of what my team owns is the algorithms that determine which ads are shown to which Waze users at what time. And so what I've seen is that there's been a huge appetite for replacing some of our more simplistic algorithms for serving ads with machine learning models in order to serve ads more smartly. So one thing that we might try to optimize is advertiser campaign delivery throughout the campaign's lifetime. And we can use ML to try to kind of optimize that campaign. Another thing that we've tried to do recently is provide users with ads that are more relevant to that user. So for example, I'm vegan, so I don't want to see a McDonald's ad when I'm driving with Waze. So these are, and there's many other projects that we have an appetite, that I've seen a lot of appetite for from the business side as well. And we have a very active data science team dedicated to ads to support all of these projects. And in fact, we have so many of these projects that we're looking to now scale our process for developing new models. And one way that we've done that is by moving from on-server models to hosted models, which is the recent implementation that you mentioned. So we had an integration with Vertex AI, and now we're able to sort of speed up that iteration process for data scientists developing ML models, because they can just develop a model and host it on Vertex AI, and they don't need to go through our software engineering release process to release an on-server model. So that's really helpful, and there's a lot of infrastructural benefits as well to having a hosted model as opposed to an on-server model where we're eating up CPU on our side.
Absolutely.
So
That's
it's been
cool.
really exciting, and it's been
No, go
exciting,
ahead.
and we're many more projects down the line, and it's lots of appetite from product.
Yeah, very cool. So I guess another topic on sort of ML maturity, I think that should obviously be addressed here is, as machine learning matures and its impact is realized, responsible AI has become of increasing importance. Ruchi, I'm really curious, how much does responsible AI play into your everyday work? Do you have an example of how you take this into consideration and maybe try to avoid pitfalls?
I believe that if an application is being released on a global scale, it's essential to take into consideration the impact it may have on different segments of the society. Data science helps us to get insights to problems as well as solve these issues faster, but it should not be at the expense of causing harm to anyone. And having said that, I think responsible AI should be an integral part of our workflows in general. And care must be taken that our problem solving approach is ethically sound. Being wary and identifying potential biases from the beginning obviously does help, but bias can creep into the process at any stage. And it could be an issue with the data having representational bias, or the model could have had deployment bias. So we really need to be mindful at every stage of the process. Model explainability and trust do form a very important bridge between people who are developing the application and people who are using it. So I think, yeah, these are some of the many things that we keep in check.
Great, thanks, Ruchi. My last question here before closing things out is, what types of tools or services are popular with data scientists who want to better understand their data and their models and the intended and unintended consequences of their model deployments? Let's start with you, Lauren.
Yeah, so first I'll just speak to the importance of this. So with model explainability, I think that most of us would agree that the ethical side of AI is the #1 priority. Another aspect of it is the business implications of model explainability. One debate that I've seen on our teams is this weighing the pros of having this fancy ML model that's smart and improves ad serving, but can be very confusing, versus a very simple algorithm where we can easily say, okay, we know why this particular ad was or was not shown to a particular user at this time. And so when we introduce these new models, we have to really manage the complexity and say, this new model is worth it because it's going to be, X percentage better than a non-machine learning algorithm. And it's explainable enough that it's actually maintainable on the inside.
Yeah, makes sense. And then Paul, yeah, you're curious for your answer.
Sure, yeah, this is a really great and a really important question. So yeah, I'd love to jump in on this as well. I think a lot of ethical AI issues boil down to the importance of really deeply understanding your data and deeply understanding your model and being aware of things like false negatives and false positives and poor performance on underrepresented subgroups, for example. And so, just along those lines, I want to point out some of the really excellent work that has been done by Google's People plus AI research team. They create tons of really excellent tools and learning resources relevant to ethical AI. And specifically, recently, I've been really impressed with the What If and the LIT tools that were recently released by this team. These tools allow you to dive deeply into both your data and your model and look at how making changes to individual data points can influence the outcomes, and look at how model performance compares against different subgroups. And basically, they just built a tool that makes all of this really quick and easy to do. And it's a great way to get to better understand your data and better understand your model, so you can be informed of and can develop a strategy to counteract any ethical issues that you might identify. So I'd encourage everyone to visit and become familiar with Google's People plus AI research team at pair.withgoogle.com. There's some really great tools and learning resources there.
Nice. Thanks for sharing that, Paul. All right. So thank you all so much. Thank you to the panelists. Thank you for the attendees for joining us for this panel session and for Google Cloud Next 2021. So as promised at the start of the presentation, here are the details of the Kaggle competition that we launched today, October 14th, and it will run until November 28th. We invite all of you to access the complete survey data, dig into it, and share with us your unique insights and your perspectives. And before we head into the QA, I'd like to actually close the panel discussion with a question to Andre, our reigning winner of last year's survey competition. Andre, we'd love to hear about your prior experience in using the Kaggle State of Data Science and Machine Learning Survey to create insights. How did you approach this massive data, and what can you recommend to those that are tackling this year's data?
Sure. So if you look back in the previous years and you look back in the notebooks that people published, you'll find a lot of very good insights in there. And it's hard to find a notebook that doesn't have a good insight. But I think the main difference, what will make your work stand out, is the polishing of your work and caring about the details. So if you just plot your data, you find an insight, you plot your data using Matplotlib or Seaborn, and you use the default settings and you don't do anything to present this data in a better way, what will happen is that the audience will have to interpret that and try to understand what that data means. And if you look at the winners from past years, all notebooks, they had very, very good and a lot of work. They put a lot of work into polishing this data, polishing the visualizations so that it's easy to see and to understand the message behind and understand the insight that was found in the data set. So yeah, that's the main challenge, is kind of finding a good insight is not too hard, but finding a good way to present it and to make it clear, that's the most difficult part. And that's what's more kind of time consuming as well. And a lot of people just stop when they publish the first chart using Matplotlib. But I think what the winners do, they go a step ahead, they go further, and they polish that data a lot to present it.
Nice. Thanks for the tips, Andre. All right, so now we're going to open up the floor to audience questions and answers. And I'll open up to our panelists here to grab any questions. What I'll do is, if you submit your questions within the chat feature of the room, then we'll over here select and answer as many of these as we can in the remaining time that we have. So I'm going to go ahead and toggle over and see what kind of questions we're getting. Don't be shy. Okay, let's see. It looks like we got a question from John. How about graph machine learning, graph embeddings, and knowledge graphs?
That's a great question, and is something we should include on the survey for next year. One just comment I'll make is recently the State of .ai report was released by a different organization not affiliated with Google. State of .ai is where you can find it, and they had a lot to say about growth and excitement with graph networks. That would be a great place, I think, to find more insights there. And I agree, it's something we should include as a algorithm choice in our next year's survey.
I'll jump in with this one just with some thoughts from it. So, again, from a lot of the enterprise perspective, graphs, very exciting. Most of the underlying ideas about graphs have been around since the early 20th century, et cetera. And I think what we see is while they are very, very powerful and really useful tools, um, they're still hard to work with inside of most organizations because for so many years we have spent our time changing our thinking from kind of graph style thinking to tabular models, right? You think in terms of CSV and Excel, and your data is shaped and formatted that way. And so as a result, like getting the fluency to be able to shape problems in a graph style instead of in tabular data is, I think, going to be a lot of change and a lot of hard for a lot of organizations because it's going to have to affect not just the machine learning algorithms that they use, but the way that they save and store data. Now, incidentally, like language models, I think are facing this same challenge, but probably coming up faster in the sense that we spent so long trying to convert raw text data into tabular information that to walk ourselves back and be able to use natural language models on raw data is still a big challenge for a lot of organizations. However, it's a challenge that, like as we've seen with some companies, is already paying big dividends to do it. So I think graph neural networks and graphs in general are very interesting. I think it's going to be a while until they become as pervasive as their power suggests.
Nice, thanks, Henry and Paul. All right, let's go next. The next question I have here is from Daniel. Will we see any new $1 million competitions in the future? I sure hope so. Having spent a lot of time on the competitions team at Kaggle, I can, say that we're always welcoming of large dollar prize competitions or just really any competition that kind of pushes the state of the art in any direction or on any topic. We'll see. We'll see. I will move on to the next question. Lucas asks, interested in how you assign a value to what analytics data science brings to companies?
I can start answering that.
Yeah.
So I think one very clear example is we have a recommendations model in place. And a very easy way to measure that is the uplift in sales. So we can measure how much more we are selling in terms of revenue, money, how much more we are selling comparing to the control group. And this gives us a clear value of kind of the return on investment we're having. So for some models, for some applications, it's really easy to get that. For others, it's more complex. For example, we have you can do this indirectly. So let's say we have some models for forecast, and we need to get ingredients in time for customers, so we can deliver the products to our customers. And in those cases, the most important thing is measuring if we are able to deliver the order in full and on time. Because we know if we deliver a great experience to the customer, they will purchase again. So we cannot measure like specifically how much money we're bringing in, but we can measure if we are delivering a good experience to the customer or not.
Yeah, absolutely. That makes sense.
I could just add on
yeah,
too. I think that, to Andre's point, I think that sometimes it can be difficult to quantify data science, but I think one thing that's true across companies, or could be true, is that data scientists can often allow an inefficiency to become visible by playing with data. So something that I've seen the data science teams at Waze do is they'll pull some of our metrics and signals and actually show us where we're not, selling ads where we could, or where our inefficiencies are in our process of serving ads, and just making that visible. Once you can see the problem, you can fix it, or you can improve it, you can optimize it. And so that's a huge value that could be quantified and just the financial impact of that product or the project. So.
Yeah, kind of a nice follow-on question actually that we just got was from David. What areas of growth do you see for data scientists? In other words, what feedback are you hearing from companies that they wish they had but has yet to be solved? Any ideas for our panelists?
Yeah, Julia, can you say that one more time? I think
Yeah,
the
sure.
question was very, very interesting.
Yeah, so he's interested in what areas of growth you see for data scientists. In other words, what feedback do you hear when you're talking to companies that they wish they had, but has yet to be solved in this field?
Yeah, I'm going to give you two totally different directions on this one.
Okay.
So one is data scientists mixing with software engineering. It's interesting. We've got Julia on the call, as well as a bit of Andre's experience too, in that data science is becoming a more and more fundamental part of building software at scale, not just like a bunch of statisticians in the basement, cooking something up in the lab or whatever. And so because of that, companies want to use ML in more cases and they want to use it faster. So becoming a stronger software engineer, and understanding good software engineering principles and integrating that in your data science is like easily one of the biggest things that I hear companies doing. On a different side of it, the other side is companies want to be able to take all this excitement about machine learning and all this hype about it and actually do stuff with it. And that's like very hard to be able to connect the hype of machine learning to actual business challenges. And so being able to think almost like a product person and being able to say, okay, here's what I need, here's what problem we have and what tools that are in my toolbox that could actually solve it, and being able to think through, what is machine learning's actual role in this one instead of just like discovering relationships with data is very important. Now, incidentally, I think that latter point is somewhat related to the needs that Ruchi brought up during the talk about impact or rather responsible AI, in that the more data scientists can think about the business problem and ask the big question of like, okay, as we solve this problem, am I going to make the world a worse or better place as a result of it, is really a fantastic skill and a great question to answer that the data scientists should continue to upskill. So thinking about business problems and the real world implications in addition to your core skills at statistics and data.
Yeah, that makes sense. I'm going to try to get in another question or two here with the remaining time we have. We've got a couple of questions that are kind of around the similar theme, each person kind of sharing a little bit about their background and asking how they can get deeper into data science. So Craig saying, can you pivot into data science without a master's degree or PhD, but some relevant BI or other background. Deepa saying, any tips for software engineers to become a data scientist? And then Anirudh asking about, I started my journey with Coursera and non-traditional or MOOC related coursework, feeling a little bit intimidated about how to approach whether it be Kaggle or furthering their career. Curious for all these different types of questions where you're saying that you come from a different path. How do you all think about progressing in data science? What kind of things do you do, or do you feel like are available for no matter your walk of life, I guess? Maybe Paul, do you have? Sorry, Ruchi, go ahead. Yes.
Okay. I was just saying that if someone's coming from a different background and not specifically a statistics or a data science background, they can start with a particular problem statement that they can relate to better, something they have more domain knowledge about, because then they would be interested to stay focused and pursue the problem to the depths of it and learn more during the whole process. So pick up any problem you like and just delve into data science.
Yeah, absolutely. And, Kaggle being a place where you could, really explore a lot of that. I was going to say, Paul, I don't know if you've had quite a bit of experience, especially coming from the, Coursera world of learning data science as well.
Sure. I think, one thing that's important to consider is that you have data analysts and data scientists in every field, just people that are thinking thoughtfully about data and trying to model it. You might find that if you're working with data and working in this field, you're closer than you think you might be, and you have perhaps some subject matter expertise in a different domain that can really help you to get started on, a really specific and applied project in a domain that you're really familiar with. And so, yeah, I just encourage, if you're coming from another field, you likely have some domain expertise there. Build a project around that, and that can be a great way to build experience.
Nice. Thanks, Paul. Thanks, Ruchi. And thank you to everybody. Oh, sorry, go ahead.
Oh, yeah, I just would like to share a little bit of my experience as well. There was a question there asking about having a PhD, right? So I never graduated. I never got an undergrad degree. I dropped off the college. So, but I'm not a data scientist. What I would like to say is kind of, I'm a data engineer today. And if you are going into the more of the engineering part, I believe you can learn a lot of the skills without needing a PhD, without needing a master's or college degree at all. For data scientist work, I believe there is more technical things you need to know, and then having a college degree will make a difference, and having a master's could make a difference. But in general, for work in the engineering part of data, it's becoming much easier to join this without having to have a formal education. And even moving countries. I was in Brazil and I moved to the UK without having a degree, and it was possible.
Yeah. Thanks, Andre, for sharing your experience. And with that, I think we are at the conclusion of this session. It's been awesome. I've really enjoyed speaking with all of our panelists. Thank you for all the thoughtful questions. And again, don't forget to check out the competition and the data that is behind this report. Thanks again, and I hope you enjoy the rest of your day.
Yeah, thanks for joining, everyone.